side event webinar of the European Sustainability Week. The session today is about decarbonization of steel industry through hydrogen. It has, I believe, in our opinion, a very important place today and this year in particular to discuss about that. We know that decarbonizing the steel industry has happened in the past and continuously happening also through other measures like energy efficiency, let's say, but there is a need for radical changes in how probably also the steel is produced. And in that way, also integrating renewable energy sources into the processes. And that we also believe, and you will see from the different presentations of some of our projects, that can be done also with the help of or via hydrogen. We will have a panel today on, we will have the different views from the policy, but also from the technical issues that still need to be solved. A bit of housekeeping. So, as I said, the session will be about an hour and a half. Please mute your microphone if you are not speaking, and also switch off video if you are not speaking. The session, the entire webinar is recorded. We will make it available later. Please put your questions in the chat. I strongly encourage to do that if you have questions for any of the panelists or for myself. And of course, all the presentations will be also shared after the event. Now, just a bit of an introduction about the fuel cell and hydrogen joint undertaking and myself. I'm the head of operations and communication in the fuel cell and hydrogen joint undertaking. What is the fuel cell and hydrogen joint undertaking, in case there are people in the audience that still do not know about it? It's a public-private partnership. On the public side, by the European Commission representing the European Union. And on the private side, the two organizations, Hydrogen Europe and Hydrogen Europe Research. It has been established 13 years, more than 13 years ago in 2008, and supported R&I, research and innovation, activities on hydrogen technologies across the whole value chain, from the research programs of the European Commission, FP7, Framework Program 7, and lately Horizon 2020. As you may know, there is also a proposal by the European Commission to prolong our mandate under the new framework for research and innovation in the European Commission, Horizon Europe. What have we done in the last 13 years? We have supported almost 300 projects for about more or less 1 billion euro in these projects. With at least the same amount of money in projects as in-kind contribution from the private beneficiaries, and of course at least the same amount in additional activities, how we call them, or the private investments by the private members around the projects we supported. As I said, we supported projects across the whole value chain. Hydrogen production projects, different routes, lately a lot on electrolysis, the different technologies for electrolysis, but also low TRL, technology readiness level type of activities on other routes for renewable hydrogen production. We have also supported projects looking at distribution or transportation of hydrogen from point A to point B. Also with on different carriers there, in particular, for example, liquid organic carriers or blending of hydrogen into the natural gas grid. We have also started supporting projects of hydrogen storage, storage for energy purposes, not onboard storage in the transport side, but storage like underground storage in salt caverns or depleted fields. And then, of course, a lot of projects at all technology readiness levels for use of hydrogen in transport applications, in cars and buses mainly, lately, coaches and trucks and moving more and more, also maritime, moving more and more into the heavy-duty applications. And on the energy side, of course, use of hydrogen in stationary application for heating, cooling, or even tree generation. As a horizontal type of support, we have also supported projects on pre-normative research, input to standards, education, training, safety, and many other activities. About 3-4 years ago, we also started working a lot with regions, and in particular with regions, with member states. We always worked, and to see exactly the interest of the regions in decarbonizing locally their economies. And as an outcome, we have also supported a few hydrogen valleys. And one of the example is the valley in the northern Netherlands, or for example, the island in Mallorca, by looking, of course, to the different archetypes of valleys. And now I'm coming, and with that I finish my introduction. I'm coming to the point of our discussion today and why we're here today. We selected 2 of our projects, and of course, like I said, we brought together with us not only our projects, but also policy side from the European Commission speakers, and also from the other sectors. We supported several projects for hydrogen into the industry, not only steel, which is the subject of today, but also we have some other examples of use of hydrogen, for example, in refineries, or in e-fuels, methanol production, or food industry, etc. For the subject of today, we selected 2 projects looking at the different solutions: the low temperature electrolysis, steam electrolysis, and the other one, the solid oxide. And you will see the successes of these projects, but also the challenges. And you will see how, with the different technologies, we have tried to get into the field and look at the solutions of, like I said at the beginning, decarbonizing of steel industry via or with hydrogen. With that, I finish, and I would like to now move already into the, and to invite my speakers, my dear speakers, to guide us through their different angles or point of views. And I would like to start with a more general, from the policy side, with a more general view on decarbonizing industries via hydrogen. And I would like to, it is my great pleasure to invite here Andrea Gentili, Deputy Head of Unit Low Emission Future Industry in the Directorate for Research and Innovation of the European Commission. Andrea, the floor is yours.
Thank you very much. Thank you very much, Mirella, for the opportunity to say something in relation to the policy objectives. Indeed, I just would like to make an intervention covering the European Green Deal first, then second, the updated industrial strategy. What is the role of industry in the context of the European Green Deal? What it is the role of R&I, research and innovation, in particular some instruments like the partnership, the joint undertaking, clean hydrogen, and other partnership like the one on clean steel. European Green Deal, most of the people think about the European Green Deal more in terms of greening than in terms of deal. The Green Deal is a deal on greening, on basically transforming the European economy for a sustainable future in the direction of greening, yes, climate neutrality, but also in the direction of digitalization, in the direction of circular economy, and without forgetting anyone. So the second, there is an element which is called leaving no one behind, which is important in the Green Deal. All right, why industry is important? Because in any deal, we need to have a partner. And industry is a partner in this transformation of the European economy. If this transformation of European economy into a fair, prosperous, and climate-neutral economy has to be achieved, we need to engage together with industry, and each industry has to have some certainty in terms of the objectives that we need to achieve together. Industry, investors, and in particular, we need to help energy-intensive industry to develop innovative and climate-neutral technologies, like the specific case of steel making. If you know, the European Green Deal is designing a set of areas, set of policies, and among those policies we have the policy related to promoting clean energy. We have the investing in smarter and more sustainable transport, or striving for greener industry. Let me just pick one, which is the clean energy transition. This is one of the 11 addressed by the Green Deal, which recognize that the decarbonisation of the EU energy system is really critical to achieve the targets of 55% of greenhouse gases emission by 2030, and hopefully the climate neutrality by 2050. And if we look at the energy systems, of course, we need to work in terms of energy system integration, but indeed hydrogen is a potential solution. Together with offshore renewable energies or other initiatives like the European Battery Alliances, so electrification. Don't forget that there is an aim in the Green Deal of 40% of share for renewable energy and 39% of improvement in energy efficiency by 2030. Now, industry, like steel or others, can also intervene in the way the products are done, in the way production is conceived. And the recent industrial strategy, which was following the European Green Deal, adopted by the Commission in May, is basically helping industry to lead this twin grid and digital transition for a globally competitive and resilient EU. There are elements related to the circular economy action plans that need to be considered, and the renovation waves, which aims to double the renovation rates by 2030 in such a way that we can also create jobs, reducing energy poverty. Now, what is the role of R&I in all of this? It's important to mention that, first of all, Horizon Europe is, as you know, the biggest program worldwide for research and innovation, and 30% of the budget, which is almost 90 billion budget for the next 7 years, 37% is dedicated for funding for climate solution. Last year, there was the Green Deal call of about 1 billion on this. We have launched partnerships in the context of Horizon Europe and missions. And partnerships like the one on clean steel or the one on hydrogens are instruments to make sure that we can develop together with industry the right building blocks and the right demonstrators in such a way that in the next 7 years we can accelerate the entry into market to concrete solutions which could be, of course, help all of us to achieve the targets of the target of 2030, in terms of climate neutrality, in terms of greenhouse gases emissions. So we think that research and innovation is a tool, is probably the unique tool at this stage to accelerate this transition. And it is indeed a key enabler for all the sectors, industrial sector, in order to accelerate this transition. Now, the green hydrogen joint undertaking, which Mirella was referring to, and the other joint undertaking, for example, in the area of transport, just aviation, are instrumental to help industry to make use of the enabling technologies related to hydrogen, and make and incorporate and embed those new technologies in some demonstrators for future aircraft from one side, from future production facilities for steel and others. So we really see the crucial role of partnership in this context. However, just developing technologies is not enough to make sure that we finally have the products up to the market. And that's why the Commission has promoted the concept of alliances. There is a specific alliance with industry in the context of hydrogen, the Green Hydrogen Alliance. There is another one in the context of electrification, in particular on batteries. Other alliances are mentioned in the updated industrial strategy of May, like the one on, for example, zero-emission aircraft, which also is expected to make use of hydrogen as a future propulsion systems for aircraft. So what are those alliances? Those alliances are elements which have to be put in place together with industry to make sure that all the stakeholders and the regulation and the legislative environment are prepared and will be modified and adjusted in order to make sure that those innovations will find an easy way to get to the market. Those technological innovations developed together in the context of the joint undertaking, the co-program partnership, the missions, and so on, can flourish and, let's say, easily reach the market without major obstacles. So, in conclusion, with my short intervention, I wanted to give you an overall policy of where we want to go. I think that with the European Green Deal, the Commission made an ambitious step forward. Never before the Commission managed to set the targets so far away in terms of timing. Targets by 2030, let's say, really mid-term, but even very long term, like 2050, when it was mentioned, is a concept of climate neutrality. And this should be like a lighthouse for all of us to guide and to drive all our joint operations. Thank you very much, Mirella. The floor is yours.
Thank you very much, Andrea. Just to, because I want to take the opportunity of audience already, how can I say, digesting everything you said, and to build a bit on that. Indeed, we have a very ambitious agenda with the Green Deal, and similarly, or accompanied by Horizon Europe and the two already partnerships, if we only talk about the steel today, so hydrogen and the Clean Steel Partnership. Do you think worldwide, internationally, because steel production, it's not a European necessarily type of industry, internationally, maybe we should also do the same? Do you think mission innovation is maybe the right tool to do something like that? What would be your opinion if we talk internationally?
Yeah. I do believe that the challenge as big as the one of the European Green Deal can only be addressed at the international level. So it's important, however, the concept which is mentioned in the updated industrial strategy of the strategic autonomy for Europe. It has to be addressed all together, but we need to make sure that hydrogen technologies for which Europe has the competitive advantage worldwide, hydrogen technology can be developed in Europe first, and we can maintain this competitive advantage with respect to other regions of the world. And I do wish that clean hydrogen joint undertaking could help us exactly in this direction.
Thank you very much for this answer. Really, I could not agree more that we need to keep the advantage, at least from the technology side, that we have for now on clean hydrogen solution. Thank you very much, Andrea, once again. I hope you can stay with us till the end for the panel discussion. And now I would like to give the floor to the second speaker, is Mr. Klaus Peters. He's the Secretary General of the European Steel Technology Platform. And of course, here also in his role of representing now the future Clean Steel Partnership. Mr. Peters, the floor is yours.
Thank you very much, Mirela. It's also my pleasure to contribute to this session in the European Sustainable Energy Week today. And of course, it's a pity that we do this fully remotely instead of, we are talking so much about collaboration, so that we cannot really have face-to-face exchanges over a coffee or so. Next one. So we have heard from Andrea about the policy setting, and I'm very pleased now looking at this slide demonstrating and showing the situation for 3 example important materials of economy: cement, steel, and plastics. And we can see by the charts that the production following the demand is tremendously increasing. So cement 3-fold, steel more than 2-fold, and plastics also 3-fold, all related to CO2 emission. If we consider the primary production as of today, cement with 1 ton of CO2, steel with 2, and plastics even with 6. And as I said, I'm pleased to hear from the policy context, the solution is obviously not to reduce these material production, but on the contrary, to enrich the world by these materials and to find technology solutions to decouple the material production from the CO2 emission. Next one. And we are convinced that the technologies fulfilling this objective are finally the winning ones, meeting the criteria scalability, affordability, and contributing to high level of circularity. And for the steel, this means we have the 2 basic approaches, starting with iron ore, the so-called primary steel making, and the second steel making route starting with scrap. Both will play a major role in finding the solutions, and still both are challenged to significantly improve. If you look into the translation into real figures on the right side, the left one is the primary production, starting with BF-BOF, blast furnace, basic oxygen furnace. Typically today it's around 1,800 kilograms of CO2 emissions per ton of crude steel. And following the objective Andrea pointed out of the Green Deal, we have to go down by 55%, meaning 810 kilograms emissions. And climate neutrality is then something like going down to 85–95%, and 85 means 270 kilograms of CO2 emissions. So these are really huge challenges lying ahead of us. And if you go, the middle is the direct reduction, and the right one, the scrap electric arc furnace, we can see that today the starting point, so to speak, for the scrap electric arc furnace route is significantly lower with 500 kilograms CO2 emissions. However, if the primary steel making does its job, and there is no reason to be not confident about this, then the level of the today's scrap electric arc furnace is challenged, because then it's double. So there also is the challenge existing to reduce the CO2 emissions. And I'm totally convinced that finally the distinction between primary and secondary will be more in a gray area. They will be much more flexible, because the more we use direct reduction, then the interchangeable between this direct reduced iron and scrap does exist. And solutions, as we already mentioned a couple of times, are highly depending on successful collaborations on European level. Next slide, please. And the leading instrument for collaboration is the Clean Steel Partnership, aiming at accelerating the work, the ongoing work, and also the planned work of the producers towards climate neutral steelmaking. The two next speakers will give impressive examples of company approaches to really make it happen that the CO2 emissions are reduced. Because the partnership, as Andrea already pointed out, brings together the public and the private side. And from the private side, it's ESTEP, the European Steel Technology Platform, very importantly supported by Eurofer. So Eurofer, the steel producers and the associations, broadened by ESTEP about plant builders, research organizations, academia, and also other stakeholders along the steel value chain. So I cannot dig in all the details of the partnership, but let me emphasize that it is all about having impactful projects, so large demonstrators, at least 4, reducing the CO2 emission by 50% or even 80%. That's the objective of the partnership, to deliver such demonstrators. And it brings also a unique element in blending financial public means. The one is 350 million euro from Horizon Europe, and the other financial pillar is coming from the European Community for Steel and Coal, so to speak, the grandfathers of the European Union as such. And this is the last bullet point indicates this very important contribution, but it's not the full financing of the need for research and innovation. Next one. And how is it organized? How can we do this, this collaboration? So if we look in the upper right picture and start with the green box, we call this approach carbon direct avoidance based on hydrogen. So now I'm using the word for the first time, and electricity instead of carbon. So therefore the name carbon direct avoidance. And going to the blue box, we may continue to use carbon, but then it is done in a smart way, meaning avoiding the emission of the generated CO2 gases by either CCU, so processing the gases into valuable products, or storing, CCS. And this is complemented by further optimization of the production, meaning smarter processes. We call it process integration. And both concepts are importantly supported by the overarching approach of circular economy. And the work done within the partnership is about collaborative research. So for also competition compliance perspective, we translated these company solutions in building blocks visualized in the 12 blocks in the lower right, where collaboration is possible. And how important is hydrogen for these? If you click once more, then some of the building blocks turn green. So you see which building blocks, how many of the building blocks rely tremendously on hydrogen as part of the solution. But this also visualizes, yes, hydrogen is very important for the vast majority of our actions, but it is also not the silver bullet. There are also other promising solutions in development and in implementation. Next one, please. And as I said, it's about accelerating towards climate neutrality and really have impactful projects so that the CO2 is safe, because the partnership is about research and technology development. The follow-up, the implementation at industrial scale delivers the reduced CO2 emissions. And this is illustrated on this slide. Two big important instruments do exist. The one is the Innovation Fund, financed by the Emission Trading System. And the other one are the important projects of common European interest. For sure, the following speakers will elaborate on these. And you can read the impressive numbers about how many large projects are already running or in an advanced planning stage, covering many countries across Europe. And the color coding on the right side is also the same one as we had with these technology pathways, so carbon direct avoidance, smart carbon usage, and circular economy. And in the middle, you can see that hydrogen is an important player. So if we just look into the important projects and sum up the need for hydrogen to make these projects happen, we see that something like 0.5 to 1 million tons of hydrogen are needed per year, translating into 10 to 12 terawatt hours per year. So these are high numbers in order to make the transition happen. And I also like to mention that it's always important to have a sustainable transition, that a supportive legislative regulative framework is in place. Next one. And to conclude, we can see that one approach to do the transition is just by color coding of your paint, as nicely done by Roland Berger on the left side. And we have to say that steel production in the very past was as black and gray as depicted here. And if you look more on the right side, we see the summary of the Clean Steel Partnership storyline, where the main actions are split up along the timeline, as well as the various areas of intervention, supporting the important objective of delivering demonstrators for the potential CO2 emission reduction of 50%. So these are the purple colors. No surprise, I guess. They are aiming at earlier years compared to the green ones, delivering demonstrators for an 80% CO2 emission reduction potential, which are planned for rather the end of the partnership. Thank you very much for your attention, and I'm looking forward to hear the concrete examples of the colleagues from the steel industry and the producers of energy.
Thank you very much, Mr. Peters, Klaus. Thank you for your intervention. Again, an immediate question would be from me, and I know it's a bit challenging to put it so bluntly, but if we would decarbonize and we will produce green, the so-called green steel, is there a lot of cost involved? What would be the extra cost of producing green steel? Just a ballpark figure in your opinion.
Yeah, so please allow me to answer from two perspectives. So the one element is that the reason why green steel is more expensive is linked to the additional energy need we have when changing to the other processes. So if you go, for instance, to this hydrogen-based steel making, something like 80% more cost is estimated, and it all depends on the cost of hydrogen. So let's wish all the success for the clean hydrogen joint undertaking to develop affordable solutions. And also in CCU, in the transformation of CO2 needs tremendous amounts of hydrogen. So the electricity price and the hydrogen price translates into this. Now, also sharing a figure with you, if we translate the extra cost into the cost increase for the final product, then the numbers, I think, are more tangible for the non-experts. And there we do have the estimation, for instance, if we go to the automotive sector, which is a very important one, and we implement our technologies, then the cost increase for a car, for a medium car, is in the area of 200 euros, which is not so much compared to the overall price of a car. And so looking at this, one answer is where does the money can come from for this challenge of transformation. As it is a social challenge, we assume that part of the cost can also be covered by all of us, which is not a unique position for steel, but others are in a very similar position. Thank you.
Thank you. Thank you for your answer. Thank you very much. And again, I look forward also towards the end to discuss a bit also with all of you to see exactly also if we get questions from the audience. I see we still have a numerous audience. So without taking more time, thank you again. And I would like to move to the next speaker, which is Mr. Simon Krupp, Research Engineer, Project Coordinator in Salzgitter, of one of our projects in steel industry, the project Green High 2, which is, yeah, you put the title on the slide, Green Industrial Hydrogen via Steam Electrolysis. Simon, the floor is yours.
Thank you, Mirella, and good afternoon. Also, thank you, Klaus, for your good introduction to the topic. Yes, since 2016, the Green Industrial Hydrogen projects are basically the benchmark for the state of art of the high temperature electrolyzer technology. And together with partners and the support of the FCHEU, Sunfire and Salzgitter are testing and developing the world's biggest high temperature electrolyzer. And in the following minutes, I'd like to show you the current project status and would also like to provide to you a glimpse of Salzgitter's green steel making strategy, because the Salzgitter group itself is Germany's second biggest steel producer, and with our integrated iron steelworks here in Salzgitter, we are producing 4.5 million tons of crude steel every year, which is about 5% of the primary steel making that has been done in Europe. Next slide, please. The prototype electrolyzer of the ongoing Green Industrial Hydrogen 2.0 project is currently being tested at Salzgitter's Iron Steelworks. The project is about operating the first high temperature electrolyzer of the megawatt scale. So we are speaking about an electrical power connection of roughly 0.7 megawatt and a production rate of 200 nomic cubic meters of hydrogen per hour. The system is fully integrated into the existing infrastructure. So it's connected to the pipelines of hydrogen, nitrogen, and also steam. And the system is controlled, same as any other production process that we have here on site, by our centralized energy control system. By doing so, we want to reach more than 13,000 operating hours during the project duration. And with that, we'd like to produce at least 100 tons of green hydrogen. By using steam from inevitable waste heat sources of the steel making processes, we want to reach electrolyzer efficiencies of up to 84% based on the lower heating value, which is quite remarkable because it means that it's equivalent to less than 40 kilowatt hours per kilogram of hydrogen. Next slide, please. The prototype system, as you can see it here in the picture, consists of two containerized units. In front, you can see the electrolyzer unit, which is in a 40 feet container. The unit consists of up to 8 modules with a maximum of 1080 SOECs each. SOEC that stands for solid oxide electrolyzer cells, which is basically the core of the steam electrolyzer that we have here in Salzgitter. Besides electricity, the electrolyzer operates with steam of a temperature of about 150 degrees C. The produced hydrogen at atmospheric pressure is then forwarded to the hydrogen processing unit that compresses the hydrogen to 10 bar. Then it dries the hydrogen and checks its quality, so whether it matches the 3.8 criteria or not. And then the HPU injects the hydrogen to our existing pipeline. Because today the steelworks has already a hydrogen demand of 400 to 450 cubic meters per hour. The hydrogen is here used on site to establish a reductive atmosphere for the annealing of our cold rolled steel products or during the hot dip galvanizing processes. So where are we now? Next slide, please. Since March 2021, we've injected more than 24 tons of hydrogen into our pipeline. The actual capacity of the electrolyzer system right now is at 50%, while we want to reach the 200 cubic meters, so 100% by the end of this year. Since May, for about 80% of the time available, we were producing and injecting hydrogen, while we were already reaching the electrolyzer efficiency target of 84% that we've targeted. The system boundary for this parameter includes the whole electrolyzer units with its balance of plant. So just as we've seen, the container unit together with its dedicated cooling unit. So we are talking in the end, when it comes to the electrolyzer efficiency, about saturated hydrogen at atmospheric pressure. Besides Sunfire as electrolyzer provider and Salzgitter as the operator, the consortium consists of Paul Wood, responsible for the hydrogen processing unit. And there's Tenova, responsible for a future rollout study of hydrogen-based steelmaking in Europe. So it's going to be of interest for the most of you. And then there's CEA, responsible for long-term stack testing of a 30 cells SOEC stack. Next slide, please. As promised, I'd like to quickly talk about our carbon dioxide avoidance approach. Thanks, Klaus, for introducing this term, and also to our timeline. So right now, we as Salzgitter are producing most energy efficiently our crude steel based on carbon and iron ore. The central process of the production route is the blast furnace. Yeah, although I think Klaus mentioned it before, the route has been optimized for decades. CO2 emissions are ultimately inevitable. Next slide, please. That's why we at Salzgitter Group were developing our Zykos project, that stands for Salzgitter Low CO2 Steelmaking, since 2015. The Zykos project is a CO2 avoidance project, and with it we want to replace the existing production route with a direct reduction plant and an electric arc furnace. Because in the contrary to the blast furnace, the direct reduction plant is not based on solid carbon as a reducing agent, but can be flexibly operated with any mix of hydrogen and natural gas. By doing so, we can substantially reduce our CO2 emissions. And the product of the direct reduction plant is solid direct reduced iron, which then has to be melted in the electric arc furnace to, in the end, produce the same amount of crude steel with the same quality as today. Yes, next slide, please. As of today, the iron steelworks of Salzgitter Flachstahl is operating 3 blast furnaces. to produce in the end, as I said before, 4.5 million tons of crude steel every year, but it also emits about 8 million tons of CO2 annually. That is equivalent to about 1% of Germany's direct CO2 emissions. With Zykos and its 3 stages, we want by 2026 latest the first Zykos stage operational. And the stage consists of 1 direct reduction plant coupled to 1 electric arc furnace and a 100 megawatt low temperature electrolyzer. This setup will already reduce the emissions by 2.3 million tons of CO2 every year. It's going to be, because maybe the question will count, so I will just go a little bit ahead. It's going to be a low temperature electrolyzer, simply due to the reason of technology readiness level. However, in the future, we see the high temperature electrolyzer as a promising technology to increase our hydrogen production capacities and also to increase the overall energy efficiency, right? Because in the following 2 steps to come, the remaining conventional production route will be fully replaced, which will lead to CO2 reductions of more than 95% in the end. And especially when you think about those 2 last stages, we see Greenlight 2.0 and the high temperature electrolyzer as a technical pre-study for an energy efficient green hydrogen production for future steelmaking, as the title of this presentation already mentioned. And with that said, I'm looking forward to answering your questions later on.
Thank you very much, Simon. I'm not going to put the question any more than about the technology. And I don't think I wanted even to put it, but it was there just in case. I don't think it's a matter of choosing the technology, honestly. And you made it very clear, we with both you have advantages and disadvantages, huh? And it depends on what you want to do in choosing the low temperature or high temperature. But then, is there any, let me put another question immediate. Is there any safety precaution or safety measures or measure that you have to put in place when installing such big equipment like electrolyzers in a steel factory?
Well, when it comes to safety precautions or safety measures, let's put it this, I mean, we have a very vast premises of a production site, and we are used to handling with different gases and different kind of gases as well. So the Greenlight project's precautions are, let's say, nothing unusual. So it's state-of-the-art safety design that has to be proved by the TÜV, obviously, for us, very important as an operator. All the pipe layout was been done according to the pressure equipment directive. Yeah, I mean, it's a closed room in the container, so obviously we have also a technical solution. So we have a ventilation, active ventilation to avoid explosive atmospheres. Plus, everything is equipped with gas detection systems for hydrogen, obviously. And same is also very important for our technicians. So when we go for service and maintenance, all the technicians, they have a mobile gas detection system on them, so that everything is safe and clear also during operation.
But you don't find that unusual? I mean, that was mostly my question. I mean,
exactly.
It's normal.
At least it's not poisonous, right? I mean, we have gases that contain carbon monoxide, and that's when it comes to operating such a system is way more complicated. Thank
you, Simon. Thank you very much for your answer. And then now I would like to move to our last but not least speaker, Mr. Robert Palmsteiner. I hope I pronounced well your names. Otherwise, apologies in advance. He's a hydrogen technologist and project coordinator in Verbund. The project that Verbund was working with us together is the project H2 Future, which is another project that we put into the steel industry. A bit different than the previous one. Mr. Paulsteiner, the floor is yours.
Mirela, you pronounced correctly my name. It's difficult. I know. I'm sorry for my last name, but I cannot change it. I don't, at least I don't want to change it. And yeah, happy to speak about the project. It's good to see that a lot of people are working on decarbonization and that we are not alone. And yeah, let's start with my input. Next slide, please. Just a few words about our background. Maybe not everybody is aware about Verbund as a company. We are electricity provider in Austria, and we are running 128 hydropower plants with a total capacity of 8.5 gigawatt. We also have 1,800 gigawatt hours of pumped storage, and this is the main asset that is involved in hydrogen as we want to start. You can see the figure, 70% of Austria's electricity already comes from renewable sources. So we have a huge number. Of course, we are gifted in Austria with mountains, and we used a lot of it. And the river Danube has the biggest slope in Austria. So we are quite easy to switch to renewable electricity. Next slide, please. And this is where hydrogen comes in. We started a journey of decarbonization already in 2012, and we are now at 96% of clean electricity production. Only one plant is remaining in the southern part of Austria, which is a gas-fired power plant, which is important for electrical grid to stabilize electricity. But we want to establish green hydrogen as a product. This is our clearly involved in our strategy, and therefore, as we have green electricity, green hydrogen is coming out, so we don't have any discussions about colors. We are focused on really green hydrogen. And why we do this in addition is you can see it at the bottom, because electrolyzer can deliver hydrogen on the one hand and can also stabilize electrical grid on the other hand. And our plant has been qualified for these grid services already. Next slide, please. So in this project, we had in total 2 general tasks. One is the design and installation of a 6 megawatt PEM electrolyzer, which we did at the site of voestalpine in Linz in Austria. And the second big task was a 2-year demonstration operation of this electrolyzer system. The focus was on the process itself, if what the quality of hydrogen is that is coming out, and we did this together with our project partners, of course, voestalpine, and the technology comes from Siemens, the newest generation of electrolyzer system, low temperature. We were supported also by K1 Med, involved in metallurgical research. Our daughter company APG is the transmission system operator of electricity in Austria, and the Dutch company TNO helps us with the global view of the whole issue. The total project budget was 80 million euros, and it was, thank you, very well funded by Fuel Cell Hydrogen Joint Undertaking with 12 million. We extended the project already to 5 years, which ends now, end of December, but we will really continue with the journey. Next slide, please. So these are the key figures of our plant, and you can see the modules on the right side. The plant consists of 12 modules. Each module has 50 cells. The total power is 6 megawatt. It's a PEM system. We started the operation of the plant end of 2019, and we are still involved in an ongoing demonstration operation. The plant can produce up to 1,200 normal cubic meters per hour. And as I said before, it can deliver hydrogen for the steel industry on the one hand, and also to grid services on the other hand. Next slide, please. We went through a lot of tasks through a demonstration operation. First, we had a phase of use case testing. One was the stress test. You can see the step curve on the right side top. Then, of course, some kind of continuous operation 24/7 to examine the full load behavior, which is not very difficult. Just go straight ahead on the highway. Then we had the balance services. Here we were qualified for the grid services. And of course, we had the use case 4 and 5 for the future integration and the current integration of a steel site. So the plant can follow every load changes. It's qualified for grid services, so it can also do load changes within the operation of a steel site. And yeah, now since October the 15th, we are in quasi-commercial operation, and this will last until end of this year. And finally, maybe in January, we have a 1 month continuous operation for testing every use case one more time. Next slide, please. So this is how we run the plant currently. You can see that the load changes very frequently. We are using price options on electricity market. We're going to a low load, which is about 1.5 megawatt, and the maximum load 6 megawatt. And in between, we try to find good options to decrease the electricity costs, which is currently a very important issue. If you look at at least in Austria and Germany, at the price market, it's really embarrassing at the moment. They are much above 100 euros per megawatt hour. Next slide, please. So this is the kind of history of our plant. We up to now, or let's say end of September, we produced more than 667 tons of hydrogen. And this hydrogen is green. It got the green certificate from TÜV. And yeah, it has a certain quality. It's not RED 2, as these criteria are more strong, but it's green. Yeah, the pressure is low. It's a low pressure system. We don't need this high pressure at the site in Linz, so it doesn't make sense to increase it. And the purity is more than 99.8, and sometimes we reach 99.9% of hydrogen purity. And if I talk about purities, the impurities are only oxygen and humidity. Next slide, please. So to summarize, the plant has a stable operation between 1.5 and 6 megawatt. One time we even tested the upper load of 9 megawatt. The plant can do it. It can be overloaded, let's say, but the environment is not designed to get such a high performance. As I said, we have no additional chemicals, so we're reaching high purities of hydrogen and also oxygen, which can be an interesting thing also for a steel site to use this oxygen also in the future. The plant efficiency is 75% as in total, and the stack efficiency reaches values up to 83% with the best modules. Yeah, it's pre-qualified, so we still participating in the balancing markets, and large steps in load changes are possible. Next slide, please. Yeah, we have, of course, a project site where you can find all the information about the project. And the last slide. This is what we intend to do further, because in Austria, we will not be able to produce all the green hydrogen that we need ourselves. It will come from other countries, from countries where the production is possible. To give you a number, for the future electricity, to get 100% electricity from renewable sources, we need in Austria additional 27 terawatt hours. And we also would need more than 27 terawatt hours for the site of Linz to fully decarbonize it. So this is such a huge step. It will not be possible or also in the future. So we need some kind of transport system, and one that we're involved in is the EUSEW green hydrogen at Blue Danube concept, where we are also project coordinators. The idea is to produce green hydrogen in countries where there is not yet a developed infrastructure of hydrogen production, to, in this example, to transport it via the river Danube to consumers, and finally to do that in the year 2030 to an amount of 80,000 tons hydrogen per year. Happy to answer your questions.
Thank you very much, Robert. I hope I can call you Robert. Thank you very much for that, and extremely ambitious projects under the EUSEW, the important projects of common European interest. An immediate question to you also, and I saw that there are some questions coming also in the chat. You mentioned something about the prices, and because your project, you present it from another kind of angle, not necessarily from the process of steel production, but more from the other, let's say, beauty of the electrolyzers, that they offer grid services. And from your perspective, how that is also advantageous. And now, do you think the electrolyzer should be exempt from electricity grid levies or taxes? And how would any benefit compare to this beauty, like I said, provision of the grid services?
Yeah. In Austria, until end of 2020, we had a phase that electrolyzers were exempted already from grids fees, and now we have a new law in Austria that they are already exempted again, and we saw this. There is a big effect to give a number. It's between, let's say, 6 to 10 euros per megawatt hour, which is, yeah, let's say, quite an amount of money, and this has effect on the production of hydrogen in electrolyzers. If we make it depending on electricity prices, yeah, it has a really big effect. And as I think, as the electrolyzer can also do grid services, so they should be also exempted, because in the future electricity market, they will be the ones that stabilizes the grids, and therefore they should be exempted, yes.
And should be recognized. I mean, this service should be recognized and somehow appreciated. Huh? Thank you very much, Robert. Now I would like to somehow open for more questions, and I will try to discuss with all of you. We still have, let's say, more or less 25 minutes for such a discussion. I would like to somehow go back to, I mean, we heard about. Let me try to set up the tone. We heard about the ambitions at EU level, the synergies that we can make with the Clean Steel Partnership, and we heard from two projects where hydrogen could play a role, and the hydrogen solutions in the process of steel production, but also in balancing the grid. So now, keeping all this very schematic, if I can say, picture in mind, I mean, I saw also a question in the chat, again, provocative, trying to choose between the two technologies. I will first put the question to you, Robert. And as I said, I don't think it's a matter of that, but just for the sake of discussing with the audience, do you think why? And the question from the chat, it says, why you have not chosen the high temperature electrolysis, the solid oxide, because you could reuse the heat from the steel plant. And then I will ask the other way around. I will ask Simon to comment on between the two technologies.
Yeah, I mean, the reason is it's true that there are many sources of heat in steel production, but the main reason was the quality of hydrogen and the process itself. It's an easy and reliable process. it has little amount of hydrogen in the plant itself, so we don't have areas of explosive protection there. We don't have any. If there is a leakage in the plant, it can be easily removed from the building, and it's not necessary to have any blowout entity there. It's just an easy process. This is important, and it's also reliable. It produces continuously hydrogen, and hydrogen at a high quality. We're reaching directly out of the electrolyzer 99.9%. This is really a high quality that is needed in the steel production. And I think these were the reasons mainly why we choose this process. And I think this plant can more easily participate in the electricity market because it can easy answer to load changes, and which is also an advantage for the electric arc furnace in the future.
Thank you, Robert. Simon, can you comment on this? I mean, I know you kind of did briefly that for the 100 megawatt, 500 megawatt plants that you have, you will go for low temperature by saying that it doesn't mean that you still do not believe in the high temperature solution. Can you comment on this?
Exactly. Well, the main advantage of the high temperature electrolyzer obviously is if you have spare waste heat available. It's a very energy efficient measure to produce hydrogen. So I mentioned figures of about 40 kilowatt hours per kilogram of hydrogen. So with a low temperature electrolyzer, it's roughly 50 kilowatt hours per kilogram. So this also means that in the end, we have a lower electrical power connection, which might be very important in the future, especially if you think about captive hydrogen production. The power connection is equally important. And so why we didn't look into the low temperature technology at that time in that deep detail is basically the fact that the high temperature electrolyzer is less mature, and so it's less known, and therefore most interesting for us for a long perspective and a long-term strategy point of view as a future technology. I also have to admit that since the beginning of this year, we not only have a high temperature electrolyzer here at Salzgitter, but also a 2.5 megawatt PEM electrolyzer. So we are not totally blind on the low temperature electrolyzer side as well.
I was sure about that. Thank you. Thank you very much. Good. So I think, I mean, without taking much time with discussing about the two technologies, there are pro and con, advantages and disadvantages in using both. And we all know indeed that the solid oxide, it has more challenges, and it is true. It is after the PEM, but it has its advantages and should be explored. And I'm happy to hear that you still consider it for your next plans. I got a very general question in the chat, which I find it a bit provocative, although it's in our, if I can say, minds lately. So it's asking if, with so many opportunities in Africa, especially with the renewables and all the potential, if I can say that you have in Africa, shall we consider maybe shifting the green steel production to Africa, is asking somebody in the chat, and exporting it to Europe instead of just importing the hydrogen? I mean, how can we benefit from the potential of renewables in Africa? Sorry, Andrea, to put you on the spot. Would you dare to give an opinion on that?
Yes, thank you, Mirella, and thank you for the question, which is indeed interesting question. My immediate reaction to this question is, from one side, Africa is an excellent partner for Europe, and there is no doubt that we need to intensify, and politically this is what the Commission is doing, the relationship with Africa, in particular the neighboring country, the north of Africa. But in relation to the concept of strategic autonomy that I mentioned in my short intervention, I wonder if steel can be considered a real strategic product for which the production should be in a way maintained in Europe. Let me mention what's now happening with the chips. You know that we do have a shortage of chips, so productions of many products are stopped because we do not have enough chips. And chips are strategic products. So the Commission is thinking exactly to cope with, to face with this challenge to launch a European Chips Act. So my first immediate reaction would be on the contrary, to make sure that the steel is produced in Europe, being a strategic product like the chip. In terms of international cooperation activities, on the contrary, I do think that there is a lot of scope for standardization activities with the different areas of the world, and in particular to make sure that we can create a market for hydrogen, a market worldwide. Of course. So developing also, why not, the necessary infrastructure that we need for this new product.
Thank you. Thank you very much, Andrea, for this. As I said from the beginning, I could only agree with you. And I believe, especially if we hold this green steel production solution, yeah, should be European. I'm always saying that, but I try to keep my own opinion to myself. Thank you very much for that. Klaus, from your side, would you try to comment on this? And then I have also a more specific question on steel production for you.
Yeah, thank you very much, Mirela. So first of all, I'd like to mention that I'm fully agreeing to the statements which I listened to from Andrea, and maybe I can add another thought. So establishing a steel production site is time consuming. It's also, even if you know the technology, it needs time. And to establish then also the relationship with your customers is also an important time consuming step. It's not that you just produce the steel and then everyone is using this new steel for any purposes. So the question, even if we consider that there is a growing steel production capacity in Africa coming, that's obviously not tomorrow. We are rather than talking about 5-10 years if we are really fast. The second thought I'd like to add to this is, why should Africa focus on steel export? So my personal view is here that Africa is a growing continent where hopefully they will also go in a prosperous way. So the need for steel for themselves is huge. Looking into the today's figures of steel consumption in Africa. So I rather see that this is an excellent chance for Africa to start in a very climate-friendly way of going in this direction and not relying so much on fossil-based energy to fulfill the needs for steel in Africa.
Thank you, Klaus, for that. I go back to Simon, and then I'll come back to you with a more technical question on steel production, let's say. Simon, again in the chat, I get this, that hydrogen embrittlement is an issue for steel processing. Does this affect the hydrogen-based steel production?
No, it's not a problem for the metallurgy side. So when it's still in liquid phase, we don't have that issue when it comes for the direct reduction plant. So there we don't expect any quality critical issues.
Thank you, Simon. And now getting back to you, Klaus. If I know, again, I'm asking maybe very challenging questions in terms of numbers or things like that. What would be the estimation of a hydrogen demand in Europe if the steel industry was to convert to direct or iron ore reduction through hydrogen? If we will change entirely that process, what would be the need for hydrogen? I think you said it somehow in one of your slides.
Yeah, so the slides covered the planned activities from the producers in regard to the EUSEW, the important projects. And your question is going one step further. And this is a very scientific or principled question I like to start in my answer with, because we are not expecting that there is only one solution. Hydrogen has a significant role to play, no question about this. Whether hydrogen is the winner takes it all solution, there are some doubts about this. So today we have something like 100 million tons of basic of blast furnace and basic oxygen furnace based steel production. So, and if we transform these 100 million blast furnace primary steel making into hydrogen-based metallurgy, the estimate is that we need something like 5.5 million tons of green hydrogen. So 5.5 million tons. And this is another magnitude of numbers we are looking at in the projects.
Okay, thank you, Klaus. If I compare to the million ton of hydrogen per year that Robert mentioned through the EUSEW, yeah, I could see the difference. Huh? Thank you. Just to stay with you and then maybe with Andrea, what would you see exactly that our two partnership will work on in synergies? You mentioned the synergies. We show the type of the projects. What would be for you the next step that we should, on which we should work together for decarbonizing steel via hydrogen? In your opinion, what would be the next step in which we should work together?
Yeah,
I think there is a quite natural transition and linkage between the two partnerships. While the Clean Steel Partnership is rather focusing on the hydrogen application, to do this in a smart way, having high efficiency, that we are not wasting hydrogen. We should not emit it into the atmosphere. We should use it for our metallurgical processes and not for heating. There are more efficient heating tools than burning hydrogen. And having said this, then we like to rely in a very synergetic way on the Clean Hydrogen Partnership to have the large scale, very efficient hydrogen production tools. And there I also think we may up with some kind of toolkit, not just one electrolyzer technology or hydrogen production technology. Maybe finally there are other. So for instance, we could also gain hydrogen from pyrolysis, which has not been mentioned at all due to the good project presentations. I don't want to doubt on this. But there are a couple of ways to produce hydrogen, and the characteristics of the single steel site across Europe is very different. So therefore, there is a good reason why we are always advertising that we need a basket of technologies, not an endless big basket, but we need more than one technology for sure to have an efficient and doable transformation of steel site by steel site. And this in particular includes also a variety in the supply of hydrogen, either on site or by the transportation It all depends. For sure, it's challenging to transport hydrogen over long distances, but some transportation is, of course, doable.
Thank you, Klaus. Andrea?
Yes, thank you, Mirel. Good point, Klaus. You know that synergies are important because, unfortunately, we do not have unlimited money available. So we need to optimize how we spend the money. So synergies are important. I think that it's important that the two communities, which are, let's say, now getting together, continue a sort of exchange of information. There are a lot of things that the two communities and stakeholders don't know about each other. And they need to, therefore, I would wish, like it was done in May, if I remember well, let's say joint workshops where we can show some success stories like the ones from the speakers from Simon and Robert. By the way, I open a small parenthesis. I really appreciate your presentations, Simon and Robert, because basically you showed that our objectives, political objectives of this dramatic reduction in greenhouse gases emission are not only ambitious, but also realistic. So, and this is important. And by the way, I also thank you because you acknowledge the contribution from the union and from, in particular, from the joint undertaking, the clean FCCH. And of course, this is very much appreciated. So what I see as a next step, continue, let's say, synergies through workshop and dissemination activities, joint dissemination activities. Let's try to find together other success stories. Nothing is more successful to convey a message than showing success. As you guys, you did it. And so this is important. And then investigate together, as Klaus mentioned, in which way hydrogen technologies can be integrated into steel production processes or other processes. So this is the way that we need to explore together. Maybe hydrogen, let's say hydrogen can be in a way, there might be other technologies more successful or less successful than hydrogen in terms of reducing the emissions in steel. It has to be discovered together. Indeed, electrification is another route. You know, from our side, we are technologically neutral. We are not favoring one or the other, but it's clear that in the strategic research and innovation of many partnerships, and I'm still for sure, but also other energy-intensive industries, chemical, cement, and so on. It's clear that hydrogen is a path to explore together. It's clear. So let's do it. And it's important, however, from the clean hydrogen joint undertaking and other international initiatives in the context of the mission innovation, for example, we need to make sure that the cost of hydrogen is affordable and the quantity of hydrogen is matching the needs of the industrial sector, the future industrial sector, in due time.
Thank you, Andrea. And now to continue on that, somehow I hook on, because I received several questions in the chat, but I will just, we don't have time to address them all, but just to continue on your very, very, very nice answer. Would you, all of you, and now I give you the floor to all of you, and I start with you, Andrea. Do you expect some changes in the geographic location of the different value chains in steel production as we switch to decarbonized steel production methods? Meaning, in the production, you may have different value chains. Do you expect a change in that, knowing that, okay, hydrogen may come from renewable sources, it may be more, if I can say, decentralized than centralized, etc.
Yeah, it's difficult to foresee in the future. So I'm not in the position to tell you this. What I would, on the contrary, expect from European stakeholders is to be able to be adaptive and resilient with respect to the needs of the future. So I don't know how the future will look like. I don't know, but what it is important is that the steel producers will need to be able to find, hopefully inside Europe, all the key elements for their supply chain. I would say not only the supply chain, but what I call the ecosystem. The ecosystem around the steel, which covers not only what it is before the production, but also what the different services afterwards. And this is extremely important. So, in conclusion, the key word for the supply chain that you mentioned, or the ecosystem, would be resilient.
Thank you, Andrea. Again, Klaus, would you dare an answer to this?
Yeah, so I like to add on the good point from Andrea. The one is to be smart in the today's existing sites. And in brackets, I'd like to recall that in the last decade, something like this, we lost something like 26 million tons of steel capacity. So there is already some adjustment and by closures, and therefore the need to adjust is obvious, bracket closed. And at the same time, I already mentioned that erecting new sites is a challenge. I think we will experience some changes. Rather not totally new sites. We have in North Europe one new investment starting with hydrogen-based steel production as a new plant. That's very interesting to follow up this success story. But what we will see, of course, when we do the transition, the place, the location where the direct reduction plants will be located, that needs to be investigated. We have heard today that some of these will be at the same location as today, but there may be also decisions to establish direct reduction units at places we are not thinking of today so easily.
Thank you, Klaus. Simon?
Yes, also agreeing with Klaus on his point, I'd just like to add the value chain when it comes to energy carrier. So, for example, for today, almost all of our coking coal that we use in our coking plant is imported to Europe. So, worst case, we would have to import all the hydrogen to Europe as we do today from our perspective. So on the good side would be that, of course, everyone is planning with captive hydrogen production. So I think we might geographically improve when it comes to energy carriers and the value chain.
Thank you. And I think it's perfect for Robert to tell us, because he's coming from a utility side, to tell us and to try to dare an answer to this question.
As I said in my presentation, the source for the green hydrogen will be in places where it's easy to produce hydrogen from electricity. So this is Africa, yes. This will be some parts of Central Eastern Europe. This will be the North Sea. So we have an initiative of the European backbone, which transforms gas grids to hydrogen grids. So these are all small pieces that have to be put together. And to mention also, there is already a direct reduction unit from Voestalpine in Texas. and it's already possible to use hydrogen there. For they will examine it and they will do it, and this could be a first step for voestalpine especially to make the first step in Texas, although it's outside Europe, but to do the second step, changing to electric arc furnaces in Linz itself. So it's here in this case possible to do one step after the other and to do this big challenge of changing to hydrogen in small steps.
Thank you very much, Robert, and thank you all. We will have I will try to wrap up, and we will have to finish. So again, really my deep thanks to all of you. Appreciated your time with us today. I think we just started to discuss, or we continue. Let me say we continue to discuss on this issue, and I'm sure we will discuss further when year by year working together between the two partnerships, like Andrea already said and Klaus agreed, between the Clean Hydrogen Partnership, the Clean Steel Partnership, and of course I'm sure we will see more projects in decarbonizing the steel industry with hydrogen. We also agree that it's a strategic product still, and I think I could only agree with that. And we also agreed that there is no advantage or disadvantage of the two technologies, the PEM and the solid oxide. And like Claude said, probably from our partnership, we should provide a toolkit in terms of technologies or hydrogen technologies for decarbonizing the steel industry. So I hope I summarized extremely quick to try to stay into the time what we have discussed today. Again, thank you very, very much. To the audience, thank you also for staying with us for the hour and a half. I mentioned that we will share the presentation, we will share the recording, and we look forward to continue working together. Thank you very much and have an excellent week. Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.